Okay, welcome to our next lesson, 4.5, circles and areas. On this particular one, we're going to work with specifically how to find the area of a circle. So students will learn how to calculate the area of a circle given the radius or the diameter of a circle. And you're going to solve a variety of questions involving the area of a circle. Now we're going to throw in rectangles and other things in here too that we've already worked on. And you would expect to be able to do circles, triangles, rectangles, and squares, and parallelograms all together. Now, before we begin, though, on page 148 and 150 of your textbook, you're going to find how the formula for the circle is derived. And if you wish, you can review this. However, we're going to just accept that the formula works. And before that, though, and before we can use the formula, we do have to go back to grade 6 a little bit and do a little bit of review on what we call powers. Okay? Because in the formula for the area of a circle, you do have a power this time. So let's take a look at powers. So in grade 6, we learned that 6 by 6 could be written as 6 to the power of 2. Now that is what this little thing here means. This is 6, the base, to the power of 2. Now what 6 to the power of 2 means is 6 times 6, not 6 plus 6, 6 times 6. If the exponent was a 3, it would be 6 times 6 times 6. If the exponent was a 4, it would be 6 times 6 times 6 times 6. You'll notice that there are 4 of them here. And we explain that down here. This is 6 to the power of 3. This one is 6 to the 1, 2, 3, 4. This one is 6 to the, you count the 6's, 1, 2, 3, 4, 5. This is 6 to the power of 5. So when you get to a question in a formula for a circle, you're going to find area is equal to pi, which we know is 3.14, times r squared. Now this r squared, and we're going to get to this in a moment, is r times r. And that's very important because if you don't get that correct, you're going to have problems. So what I'd like you to do is take a look at this next example with 8s. I want you to write the powers for 8 times 8, 8 times 8 times 8, and the last one, 8 times 8 times 8 times 8. So take a moment and do that. Okay, you should be done. Since there are 2 of them here, there's 2 there. Since there's 3 of them, that way. And since there's 4 of them, there's 4 there. Now remember, this is 8 times 8. That gives you 8 squared. 8 plus 8 is not equal 8 squared, okay? 8 plus 8 is 16. 8 times 8 is 64. These are 2 very different questions. You can only convert powers, bases into a power like we just did here. We can only do that when we're multiplying. So, in the examples, if I had radius times radius, what would that look like when you were writing it? Well, since there are 2 radii being the plural of radius, you never say radiuses. All right, since there are 2 radii being multiplied by themselves, the answer is going to be radius with brackets with a floating 2. That means you're going to take radius and multiply by itself 2 times. So in the formula, they use r. All right, so for r, it's going to be r times r. So by the same reasoning, this is going to be r squared. Now we normally don't put brackets around variables like that. We just put the 2 floating right on beside the r itself. So anything that's raised to the power of 2 means you multiply it by itself 2 times. Now this is probably the most important part of the formula for the area of a circle. Because if you don't know that r to the power of 2 is equal to r times r, every question that you do is going to be wrong. Okay, now let's go look at the formula itself. Now that you know the power stuff, the formula to the area of a circle, area is equal to pi, 3.14, times radius squared, or r times r. So the area is the a, right? That's what that variable represents. And of course, we're always going to use 3.14 for pi, and the radius will always be given to you. Okay? So my calculator smartboard here just died for a second, so it'll start up in a second. Hopefully, give me back a green light. There we go. We're back in. Okay, so let's take a look at a question. we have a radius here. Remember, radius is halfway across. Diameter would be all the way across, right? We're not given diameter here. We're given radius, so we don't have to worry about any converting here. And we're taking a look at the area of the following circle. Now, you put down the formula. Area is equal to 3.14, pi times r squared. So then what happens is you're going to take the pi and you're going to do the substitution. Pi is 3.14, so put the 3.14 in there. Now the r is an 8, right? We get that from over here. It's in the question. That 8 goes in here in the place of r. Now remember, it's r squared, right? So that 2 has got to be there too. So this would be calculated as 8 squared is going to give me 8 times 8, and that's 64. So that's where this 64 comes from, 8 times 8. Once I have the power calculated, 8 times 8, now I can go in and multiply by 3.14, and 3.14 times 64 is 200.96. Remember, we're doing an area, so we're working with centimeters squared. I got centimeters from the question right here. We're working in centimeters. In your calculator, the easiest way to calculate it is to go 3.14 times 8 times 8, and then press equals, and it will give you 200.96. All right? So let's go to the next question. Here we go. A circle has a diameter. Now this one's slightly different. In this case, I'm given the diameter. Remember, the formula is pi r squared, and r is radius, right? So before I can calculate or do anything here at all, I've got to change the radius, so the diameter here, which is 12, and I need to work with just half of it, because that's the radius. So this is where the 12 divided by 2 becomes 6 centimeters. Once I have 6 centimeters, I can continue doing my question. So what I'd like you to do is I'd like you to stop the recording and finish this question for me and find out what the area of this circle is. Okay. We got the area is equal to pi r squared. Got our formula? Check. Now we have to put in our values. Trying to find area, we don't know what it is, so we just put down the a equals. Pi is always 3.14. It never changes. The radius, I get that from half of my diameter. We just figured that out here. That's the 6, and that's squared. So this is going to be 3.14 times 6 when you use your calculator. Now I'm not going to be marking that. That's just going to show you how to get it. So when you take 3.14 and you multiply it by 6 and then by 6 again, let's grab our calculator. Come on. No, I lost. There we go. Okay. So how does this work out? I'm going to take 3.14, multiply that by 6, and then multiply it by 6 a second time, press equals. So your final answer is 113.04. And remember, it's an area and working in centimeters, so it is centimeters squared. Okay? So what I'd like you to do now is, rather than fill your notes with a whole bunch of repetitive examples, I'd like you to get your Corel Scribbler or a piece of scrap paper, and we are going to do some extra examples until you can figure out how to, figure out or get comfortable doing this. At any time you want to fast forward through some of the examples when you feel you're good enough or you're comfortable enough, then go ahead and do so. But for now, I'm just going to do some extra examples. Okay, so circle. I'm just going to draw the circle. We'll do first ones with just some examples with some diagrams involved. Okay, so here's my circle, and I'm going to tell you that the radius is 5 centimeters. I want you to find what the area is, and I'll even give you the pi r squared to start with. So find me the area of that circle. So pause the recording and then find the area. Okay, the first thing you need to do is you got your formula down. Check. Area is equal to 3.14 times 5 squared. So when you calculate that, it's going to be 3.14 times 5 times 5. Okay, so grabbing your calculator. Alright, so I'm grabbing this. 3.14 times 5 times 5. So 3.14 times 5 equals 78.5. So the area of this particular circle is 78.5. I was working in centimeters, so it's centimeters squared. Okay? Any questions on that one? Okay, well, I guess I keep forgetting you can't answer the question. Okay, so grab another, go over here to the side of this. This time the circle is going to be slightly different. I'm not going to give you a diameter. A radius. This time I'm going to give you a diameter. In this case, the diameter is 14 meters. It's a really big circle. I want you to find the area of this particular question. So pause the recording, and let's see if you can do this. Okay, the first thing about this one, what you have to understand is your formula, area, is equal to pi r squared. Pi r squared means we're working with radius. That's what the r is. Now, this is a diameter. It's all the way across the circle. I need the radius, which is only half of this. So since it's 14, half of 14 is equal to 7 centimeters. So I need to use this. My radius is 7 centimeters. All right, now we have to use the formula. Area is equal to pi r squared. Check. Area is equal to 3.14. And now I can use my 7 squared. And on your calculator, 3.14. 3.14, multiply that by 7, and then by 7 again, and that gives you 153.86. And our units are centimeters, so we are in centimeters. Okay, so I have now given you two examples, one of each type that you have to be able to do. Okay, now we will be doing backwards questions a little bit later, but not right away. All right, because that requires square rooting, and that's going to require you to have more understanding of square roots and stuff. So that's going to stay probably to grade 8. Okay, so here's our last example. Here is our next one. Now this is a particularly strange question, because what I'm asking you to do is basically find the area that is in the middle. It's kind of like a donut. How big is the hole? So to do that, it's a two-step sort of situation. First off, you have to find the area of the big circle. So that means basically everything. And then you have to take away the area in the middle. Punch it out. What you get once you've punched it out is the area of the donut. Now there's a lot of different questions around here. Some of them have a donut which has a big circle with a small circle in the middle. Some of them might have a circle with a square in the middle, and you have to take the square out to find the area around the outside. Some of them might be a square with a circle in the middle, and you have to take the square and take away the circle. We're going to be doing a lot of these questions, so let's get started with this one here. This is probably the basics. So we have two circles. We have a big circle and we have a small circle. And we have to take the big circle and subtract the small circle's area from it. So start by finding the area of the big circle. So what I normally do is I label big and small just to make Mr. Reedy understand what I'm doing. The big one, the area, is equal to pi r squared. The formula for the small one is also pi r squared. Nothing changes there. Okay? So the first thing we have to do, sorry, back up here, I wanted to make sure that I haven't skipped any diagrams, is find the area of the big circle. Well, it tells me that the big circle's radius right here is 14. So I can put that in my formula. My area is equal to 3.14. Pi never changes. My radius is given to me. That's 14 squared. All right. So using my calculator, 3.14. I'm just going to grab it and drag it down here. I suppose. Come on. I'm going to make it smaller so it'll fit here. All right, here we go. So I have 3.14, and I'm going to multiply it by 14 twice. 14 times 14 and equals. So that means that this is 615.44. All right. So there's the area of the whole circle. So this right now, I've calculated the area of everything. So now I need to know how big is the hole I'm going to remove and punch out of there. Well, it tells me that this small circle right here, the part I'm going to take away, has a radius of 10 centimeters. So I'm going to calculate this area using 10. So it's 3.14. That doesn't change. Multiply by 10 squared. So this becomes 3.14. And I'm going to multiply that by 10 twice. So 10 times 10. Okay, and that gives me 314. All right, so now that I know the area of the big circle and the area of the small circle, I can take the area of the big circle, which is 615, and I can subtract the area of the small circle, which is 314, and whatever's left will be the donut shape that's there. Okay, so just to make sure everybody understands what I'm doing, I'm going to put down what I'm doing. I've got the area, okay, it's going to be equal to big, take away the small. What I'm going to do, I'm making a plan. Okay, so in this case, the big is 615.44, take away 314. So on my calculator, I've got 314. All right, so let's take a look here. So 615.44, and I'm going to subtract 314 from it. That gives me 301.44. And we are working in centimeters, I believe, and that would be squared. All right, so how did I do this? To find the area of the crosshatch, I took and found the area of everything. That's what I did right here. Area is equal to pi r squared. Area is equal to 3.14. Using the radius of the large circle means that the area of the whole thing is 615.44. Then I found out the area of what's in the middle. Okay, and that has a radius of 10 centimeters. So formula, substitution, answer. That has an area of 314. So then I took the area of the whole thing, 615.44, and I removed the middle by subtraction. So that means 615, take away the 314, means that I get 301.44. Okay? I hope you understand. Okay, so let's go to the next question. I'm going to give you, let's go to our scribblers for a second. So grab your quill scribbler or a bunch of some scrap paper. Let's do a couple of these subtraction questions so you can get more comfortable doing them. Okay, so let's take a look. The circle, first off. The circle has a radius of 10 centimeters. But inside it, it's going to have, rather than another circle, this time it has a square. So here's my circle. Okay. And inside this circle, I have a square. Now, this isn't the scale, but the radius of this circle is equal to 10 centimeters. The side length of this square, remember all the sides are the same, is 3 centimeters. Now, we have an area here that I'm trying to find. That's the area outside the circle, outside the square, but inside the circle. Okay? So this is the same thing we're going to do just a minute, like we did a minute ago. I need to find the area of everything. Okay? So once I find the area of everything, you're basically going to have this. Okay? Once that's done, then what I'm going to do is I'm going to punch a hole in it, and in the hole, you'll have, when I take this out, what you'll have left is the blue. So I need to find whatever's blue first, right? Once I have blue, I know this is 3 by 3, I can then find out what the area of the square is and subtract that. So let's start with a circle first. The area of a circle is area is equal to pi r squared. In this case, my area is what I'm trying to find. Pi stays as 3.14, and my radius is going to be 10 centimeters. I was told that. So that's 10 centimeters squared. So now, 3.14 times 10 times 10, it's 314. And you can put in centimeters squared if you want at this point. It's an internal calculation, so it's not exactly needed right away. Now, to find the area of a square, since a square is a rectangle, you can use length times width, or you can use side times side. In this case, they're both 3. So in this case, 3 times 3 is 9. All right, very tiny square. So now, what we're going to do is we're going to take and subtract the circle. We take the circle and subtract the square. Now remember, this is not the scale. The square is actually really small because the square only is 3 by 3. This circle has an area has a radius of 10. Okay, so it's really kind of small. So the area of the crosshatch, or that I'm trying to find, is going to be equal to the circle, subtract the square. So the area in this case, the area of the circle is 314. The area of the square is 9. So 314 take away 9 is 305 centimeters squared. Okay. So what I'd like you to do is I'd like you to cover this all up, draw the diagram, and try to do the same thing again without my help. Then back up a little bit and watch the solution and make sure you got it correct. All right? Once you've done that, we'll go on to our next question. All right. Let's see how you can do with a reverse sort of question. This time, I have a rectangle. The rectangle is 12 by 9. Okay? So this is 12 centimeters. This is 9 centimeters. Inside that rectangle, okay, there is a circle. And that circle has a radius of, where's my circle maker? Here's your circle. Let's see if we can make this work. The circle has a radius of, there's 6 halfway, so let's say 4 centimeter diameter. All right. Now what I'd like you to do is I'd like you to find the area outside the circle, but inside the rectangle. So pause the recording and see how you do. Okay, you should be back. Let's take a look. First off, the area of a rectangle is length times width. So your area of a rectangle should be 12 times 9. So in this case, that's 108. 108? Let me double check that. My brain just had a momentary lapse here. Not 12 times 9. I go 9 times 12 equals, yeah, 108. Wasn't quite sure what else. My brain was playing tricks on me. Okay, so now I have to do the circle. The circle area is equal to pi r squared. So area in this case is 3.14. My radius I've given is kind of tricky here. I only gave you a diameter, so this time my radius is 2. So here we go. This is a 2. So 3.14 times 2 squared is 12.56. All right. So now that I have that, the area of the shade is going to be equal to the rectangle. Subtract the circle. So I have the area here, 108. Take away 12.56. So on your calculator, 108 take away 12.56. Your answer, 95.44. Remember, we're in centimeters, so that is centimeters squared. All right? Now, let's try the next one. This time, your drawing is a circle with 2 circles inside it. So let's take a look. Here's my large circle. Okay? And inside here, I have a circle. I don't know if I can make this work, but I'm going to try to make it work. I need to have 2 circles which are identical. Okay? So let's see if I can make this work here. Paste that. I wanted to have them side by side so they're perfect. Okay? Alright, so I'm not quite this proper. Let's see if I can make it work here. There we go. Okay? Not perfect, but close enough for what we want to do. Okay, so what we have here is a radius, so the large circle has a diameter of 20. This has a diameter of 20 centimeters. These 2 in the middle have diameters of 10 centimeters. So what I want you to do is I want you to find me the area outside the 2 small circles, but inside the big circle. All right, so go ahead and do this. Remember that these are diameters. Your formula works with radius. So you're going to have to make sure you keep track of what the radiuses are for this question. So pause the recording and then try it. All right, so the first thing we need to do is to find the area of the large circle. So that's pi r squared. So in this case, our area is 3.14. Now, down here, my radius is 20, so my big circle has a radius, sorry, my diameter is 20, and my big circle has a radius of 10. Remember, radius is half of your diameter, so you divide by 2 to get radius. So that means this is 10 squared. All right, so in this case, 3.14 times 10 is 314. Now the small circle, there's 2 of them. So we have 3.14, that never changes. My diameter here is 10, and I need a radius. So that means my radius is 5. All right, so now on my calculator, I need to find out what 3.14 times 5 times 5, that is 78.5. Now remember, I have 2 circles here. They're identical. They're both 10 centimeter diameters. So I can take this 78.5, I can multiply it by 2. That gives me 157. So to find the area of the shaded part, I need to take the area of the big circle and subtract the area of the, I guess this is big, and subtract the area of the small circle. Okay? So in this case, my area is equal to 314, take away 157. So 314, take away 157 equals, oh cool, it's actually equal to 157 also. And that is in centimeters squared. All right. If you have any questions, go back over these examples until you can do them confidently. Let's go on to our next question in your notes. All right, this is a simple one. I want you to take, now that you've done a bunch of them, what is the area outside the circle but inside the square? Right? So you need to know what this is. So I'm going to give you a hint. Here's your hint right here. The radius from here to here is 8. Remember, this is halfway across. So that means from here to here is also 8, and that's only halfway across. So there's your hint. I want you to take and pause the recording and solve this question. All right. Now, this is a square. That means that from here to here is 8. From here to here is 8. So if both of these sides are 8, that means that this length from here to here is 16. Now, being a square, that's also 16. So my length and my width are both 16. My radius of my circle, I'm going to use that in a moment. So to find the area of the square and subtract the area of the circle, that will give me the area of the crosshatch. So let's start with the area of the square. That's length times width, or side by side. We know it's 16 times 16. So that is 256, and we're in meters. So there is my first one. 16 times 16 is 256. Now let's find the area of the circle. That's equal to pi r squared. So in this case, area of the circle is 3.14. And the radius is 8. So 8 times 3.14. Bring down your calculator. Okay, so 3.14. Multiply that by 8 times 8. Means that this is 200.96. Don't forget this is 8 squarish. Don't forget to put that in. Okay, so 3.14 times 8 times 8. So now that I have those two, the next step is to find the area of the parts, which, the shaded part only, just this outside part. So in this case, your area of the shaded part is going to be equal to the square, take away the circle. So the area I'm given is 256, take away 200.96. So on my calculator, I have 256, take away 200.96. That gives me 55.04. So my area is equal to 55.04. And now check for your units. We're in meters, so it is meters squared. Okay. So if you have any questions on that one, go back over it, double check it. How would I mark this? Formula, substitution, answer. Formula, substitution, answer. All right. What you're going to do, and what you did and what you got. Okay, so kind of like formula, substitution, answer on the last section also. All right, here we go. Remember that double circle question inside a big circle? Here's a double circle question inside of a rectangular, sorry, I guess it's a rectangle. Okay, now this rectangle is 40 by 30. You can see this here. Here's your 40, and this is 30. So we know the size of the rectangle. And you have two circles in here, but they are not the same size. This circle has a radius is equal to 10 centimeters. That's given to you right there. This circle has a radius which is 8 centimeters. So even though they look like they're the same, there is a slight difference. So the overall plan is I've got to find the area of the crosshatch. That's going to be equal to the area of the rectangle. Take away the area of the small circle, and also taking away the area of the large circle. So let's have you pause the recording and try that question. All right. First off, let's start with the area of the rectangle. The area of the rectangle is length times width. So I've got 40 times 30. So that is 4 times 3 is 12 and 2 zeros. So there is my area of my rectangle. The area of the small circle, pi r squared. So your area is 3.14. The small circle has an area of 8. So in my calculator, I'm going to pull out, I've got 3.14, and I'm going to multiply that by 8 twice. That gives me 200.96. Okay, now I'm going to do the area of the large circle. My area is equal to pi r squared. Your area is 3.14. Now the large circle had an area, sorry, radius of 10, so that's 10 squared. So 3.14 times 10 times 10 is 314. So to find the area of the crosshatch, okay, I need to take the rectangle, subtract the area of circle 1, the small one, and also take away the circle area of the large one. So what does this look like in terms of numbers? Well, you have your area is equal to 1200 minus 200.96. Also take away 314. So when you put that into your calculator, you have 1200, take away 200.96, and then take away 314. So that means my final answer is equal to 685.04. Now just a quick check to make sure our units are correct. We're working in centimeters. Yep. So our answer is going to be centimeters squared. All right. So that takes care of this. Rewind it. Watch it as many times as you need to. Once that's done, start your assignment. And we'll see you next lesson.